Nitish, why your
Good
friends are
evening,
late? Good evening.
last class except me and Kongwell, everyone came at like 15, sir. 5:15, sir. But
That
now
is
I
bad.
think I'll come.
That is bad.
I think I'll join, sir.
Are you practicing questions at home?
Yes, sir.
Good.
Today we're gonna do Newton's laws of motion.
Study Newton's laws of motion. 3 laws
Yes,
are there. We'll study deep about that.
yes. One second.
We'll wait for 2 more minutes and then we'll start.
Sir. Yes.
Hi, Nitish.
Tell hi to sir. Why are you telling hi to me there?
Oh, I thought sir didn't come because I thought like sir usually joins like with his name,
You
right?
came late.
Huh?
Am I late ever? Am I been late ever before?
No, sir. I'm just saying you always come with your name, right? So you always come with like others or something like that. So you never like come with learning room, right? So only the host comes with learning room. So I thought sir still didn't come.
Actually, we have been
Last
given
class,
with the
Pankaj didn't
authority to
even
join
come,
with
sir.
the official login ID. So we are joining with these login IDs, and then what I asked you earlier in previous classes is that please join not at time that I like the most. I like people who come at time.
It means everyone likes me.
Nitish was there on time, circle considerable, 2 minutes late, but rest, where are they?
The last class he came 32 minutes late, sir. I'm left
Sir,
in 3
sir,
seconds,
they keep change. Sir, they keep changing the times.
Hey, they don't
It
keep
was
changing. It was 5 o'clock for like past 2 weeks, sir.
No, it was not
Yeah,
5 o'clock.
It was asked Kunguril. It was 5 o'clock. Every
it was 5
Wednesday
o'clock
alone.
for me today. It was some
Yes,
kind of shift was there on today's side just when they told me to take the class
every
at
Sir,
6
it
Wednesday
itself.
was
is
only
5
for
o'clock only.
today.
No, every Wednesday it's 5 o'clock only. Past 2 weeks it was 5 o'clock every Wednesday. Sir class alone was shifted.
Not only first weeks. Ever since
Pankaj
the
said they
first
keep
timetable,
on.
Now we'll
it's
be starting.
quite
We'll be starting the further classes. Switch on your videos. Let us start with it.
Yes.
Let's dive into physics.
Yes.
Okay. So Newton's first law of motion.
Law of inertia. I mean, motion or
Let me
inertia.
look at my notes. Okay. So Newton's first law of motion. First, we'll go with the statement. Right.
Inertia is the tendency.
Yesterday
for
we dealt with the theoretical aspect. Na? We dealt with the theoretical aspect.
Yes, sir. What, sir?
It says that if is in state of rest. State of rest. Okay.
Are you writing something?
I'm not able to see
Okay,
this
now
on the
I can.
screen.
Now I can see. Yeah, now I can see.
It will remain In the state of rest,
Sir.
state of rest, and
Your screen
if
is grey, sir.
it
Sir,
is
screen is not
in
visible.
state of motion,
Oh, now
Yeah,
it's
now it
visible,
came.
sir.
it will remain moving in the same
In the
direction.
same direction and speed unless and until an external force is
An
applied.
external force is applied.
In the same direction with the same speed.
See, your
Sir, but-
screen is stuck, sir.
Sir, but
Unless and until
this law of inertia of state of motion is not possible
unless
in
and until
like our Earth, right, sir?
an external
it is
force
not.
is applied on it.
Huh? Yeah,
Sir, can you
sir,
hear
but,
us?
like, in Earth there is external force everywhere, sir.
You can create a vacuum chamber.
Everyone understood?
There's still gravity.
Sir, can you hear us?
It's on your
Sir, can you hear
videos.
us?
There is gravity in a vacuum chamber if you put it on Earth. There's still gravity.
No, I'm not able to hear you all.
So you can't hear us, okay? Who sent that?
You, what's the problem there? Mm-hmm.
Yes, I'm unmute. I was unmute, sir. Oh wait, sir can't hear
Can
us.
you hear me? Any? Can't hear.
Hey, no one can hear, sir. Sir can't hear anyone.
It's like sir can hear you, but not us three. Like, what do you mean? It makes no sense.
Can't
Can
hear
you all
anyone.
try to speak?
Tarun makes the impossible.
Sir, we are speaking.
Sir, we are speaking now. Sir,
Not audible
we
to me.
are speaking now.
Can you all rejoin?
Yes,
Can you all
sir.
rejoin?
Yeah. Bye bye, everyone.
Am I
Sir, can
audible?
you hear us? Sir, you are audible.
What did you say, Sankar? Oh, okay.
I need to rejoin then. Just a minute, I'm rejoining.
I am co-host. I can do whatever I want.
He didn't leave yet, huh? Kongwela.
He left.
Kongwela.
He kicked himself.
Now who's the host? Let's see. Learning room is the host.
Why hi? We can hear you there.
Now you are audible.
You can hear
Sir,
us,
am I
sir?
audible?
Yeah.
And
Now you are all
are
audible.
we audible?
Yeah. You are all audible.
Yes.
Hello, sir. Can you hear us?
Yeah. All of you are audible now.
Okay.
Okay. So till here you understood, everyone?
Yes, sir.
Yes,
Nitin?
sir.
Hey, whoa, how did you write all this, sir?
So when
Pardon?
did you write? Sir, when did you
Sir,
write all
your
this,
screen was
sir?
stuck, sir.
This one statement. Have you written this or not?
No, sir, your
Okay,
screen
this
was
one.
Your
stuck,
screen was
that's why.
stuck, sir.
So start writing, start writing.
Sir, just read it once again, sir.
Okay. So according to Newton's first law of motion, if a body is in a state of rest, it will remain in the state of rest, and if it is in state of motion, it will remain in the same motion with the same speed in the same direction until and unless it is provided with an external force
Oh, okay.
or external force is applied on it.
Oh my god,
You
you
stopped
you
your
stopped
screen
screen sharing again, sir.
sharing is stopped, sir.
Hey, on your video, Kongwell.
Hey, Taran, you're still wearing
Ah.
school shirt. Ada.
Hey, the guy all the time swear screen school shirt, ra. Sir, are you there?
Yeah. Is this writing screen visible?
Sir, your writing screen is not visible, but the participant screen is visible. You stopped your screen share, sir.
I don't know what's happening today. I guess some network problem would be there. Now is it visible?
Yes, sir. Yes, sir.
Yes, sir.
Okay. Then we have to learn about inertia. What is inertia? Okay. Inertia.
So inertia is the tendency of an object to stay at rest or to continue in motion.
That can be one of the definitions. So the property of an object by virtue of which it neither changes its state, neither.
I hate this, sir. My computer died again, sir. Sir, I hate this. Sir. My
What
computer
happened?
died again, sir.
RIP.
My computer died again, sir.
How many times will your
Will you
computer
invite
die,
us to
sir?
the funeral? Will you invite us to the funeral?
Still writing everything, sir. So don't
Screen is
delete it, sir.
visible now. My screen is visible to everyone.
Yes, sir. Yes,
Yes.
sir.
Okay.
Sir, but I'm still writing
It's
it
called
because
inertia.
left, sir.
Okay. It's called inertia.
Sir, but in vacuum, every like every object's tendency to like every object's inertia will be equal, right, sir? What did
See,
you say, sir?
inertia is a measure of mass. Inertia is a measure of mass. Okay. So the mass, whichever the mass will be greater, the inertia will be greater. For example, the tendency to be at rest or be in motion of an elephant will be much greater than that of the tendency of an ant. Are you getting my
Sir,
point?
but in vacuum there is no gravity, nothing. So everything's inertia will be zero, right, sir?
That force is not
every-
there, but that is a different case. That is a different case. That is a totally different case. You don't have to consider that thing, because what happens is there are few more things that is to be considered when you're talking about vacuum. Okay, so let us not talk about that, because vacuum we have to consider different things. Different forces are there. Okay, different environment is there. Many things has to be excluded. Friction cannot
Yes, sir.
be applied. You cannot apply the attraction, but still there is some kind of attraction between the bodies. They are moving with that respect. So different things are to be considered, and you don't know all the terms. and even I cannot
Yes, sir.
explain all the terms to you at this particular point. So let us exclude that. Okay, discussion.
Yes, sir.
Talking to the normal conditions, we have the
Excuse
inertia
me,
is
sir.
a kind of measure of mass. If somebody asks, yeah,
Sir, so let's say I go release like a tank of oxygen and in the vacuum, what will happen, sir? Like where
You'll
will
be
the
able to see
oxygen go?
oxygen.
molecule will just go far upon each other, apart each other.
No, sir, they won't like
Sir,
separate, right,
oxygen
sir? The
will, like,
water,
go
I mean, the
so
oxygen molecules will be together, right, sir?
Gases molecules are in random motions, okay,
No,
and they
sir.
try to be far
Well,
apart from each other. So they'll
Okay.
so that means when I release
your
a
one
tank
tank of oxygen won't do anything.
sir, that means there is some air in the like the vacuum, right, sir?
Have you ever heard of a man who
vacuum
No, no.
means
opened an oxygen tank in the space?
If you are talking about, if you're talking about space, if you're talking about space, so nothing will happen. If you're talking about creating vacuum in some closed chamber, like 2 meters, 2 meters, and then you're releasing the air inside it, so this is then not called the vacuum. Okay, in space nothing will happen.
Yes.
That is
So
too
nothing will
much
happen.
less
Like
for
where will
the
that
space.
oxygen go?
Just like if you throw you out in the
Molecules
space,
will
you'll
travel
be
far
flying
apart.
away.
Okay.
Like throwing you
They
in
will
Molecules
be
will travel
one
far apart.
oxygen
Can you go to
molecule.
the so can you go to the
One
previous
oxygen,
slide once? I'm in the last slide.
one oxygen molecule will be like 1 light year away from the other one.
It's like throwing you into
They'll
space.
travel
Whatever
far
you do with the
but
oxygen
as
do.
far as they can.
You know, I should not throw space cargo.
Bruh.
So you can
Written,
see.
everyone?
Yes, sir.
Yes, sir.
One line also. Inertia.
Yes, sir.
Inertia. You add here.
Inertia.
Why this happens sometimes? Just a minute. Inertia is a measure of mass. Okay. We can write it like this. Greater the mass, greater will be the inertia.
Yes.
Understood? Like for example, inertia is what? It's a kind of tendency to remain at its state, whether it is in rest or is it in motion, or it is motion in a particular direction. So which has got the greater inertia? Like if an ant is moving in a particular direction, if an elephant is moving in a particular direction, so which one has got the greater inertia?
Elephant. The elephant.
Elephant.
Elephant. Why? Why
So
elephant?
because it has more mass.
More
and more
mass.
mass is directly proportional to inertia.
So, what are all the deciding factors of inertia?
Speed, mass, size, I guess.
Speed.
Basically, see, there are three kinds of
Speed
inertia.
is also-
So can we tell that inertia is the
Basically, there are
tendency
three.
can we tell that inertia is the tendency to remain on the same, on the same state of an object?
That's what sir wrote, Ra.
You're reading from the book,
Yeah.
da.
That's what sir wrote also. He just didn't write the word tendency. He wrote the same thing. Oh,
So instead of this big definition, you can write it this small.
it's not big, Dad. You can write it in your own words.
But it's
When it's at
compared
rest, it will remain rest. When it's at motion, it will remain in motion until it stops. That's it. But don't
That's a
write it
big
like that.
gap.
That's dumb.
Guys,
Don't write
is
like
it
that.
only for you that
No, he
there was
stopped
a
screen
black
sharing
screen?
and his video is black.
Not the
stopped
video,
screen
the
sharing.
screen share.
No, I'm saying.
Nitish
he
is very
stopped
weird.
screen-
You know
What did
why?
I say? Because I asked
He's
SpongeBob
wearing
in the
glasses.
house.
He's wearing gloves in his hand and writing.
I know, I was gonna
No,
say
da,
that.
sweat. I have sweat. sweat. You saw in Tamil class, no, my
Is my screen
chest
visible
pressure
now?
was covered.
No, sir,
Yes,
it's
no,
not.
sir. So,
So I can't see the screen. So it's gray. I mean, now I
Good.
can see, sir.
now
But you
we can
didn't
see.
write.
Now we can see, sir.
Okay.
Yes, sir.
Yes.
Sir, turn off your video, sir. It's okay. It might like flash.
I
But Congrats should turn
think
on.
some problem is there in the video itself.
Yes, sir. If we all turn on our video, it'll take so much.
Sir, are you writing something right now?
Eh.
No, I just wrote the previous notes that was not there. Greater the mass, greater the inertia. Now we have to continue with the classes. Okay, now see here. As I said that greater
We
is the
can't
mass,
see
greater is the
anything,
inertia,
sir.
and
It's a
greater is the
blank.
tendency.
It's a blank slide. It's a blank slide.
No, he didn't write anything yet.
Blank slide. It's a blank slide.
Okay,
I'm not
okay.
written anything. Okay.
Yes, sir.
Okay. So next thing that we have to do, we have to see different kinds of examples.
Sir, you're on mute.
Based on this first law. Okay, the first
Oh,
example
yes.
that we
Sir, we can't
see is that when a
I can't see anything. It's gray.
We
Now
can
I
see
can
it.
see, but I don't think you're writing anything, so.
I'm not writing anything. I'm just explaining right now.
Okay.
Okay, sir.
So see here, now I'm writing. Can you see this point one?
You're not
No,
writing.
sir.
No, sir, we can't, sir.
You're not writing at all, sir. It's not
Nothing
writing.
here.
There's nothing there. So I'll write, sir. You just there's no annotated.
Sir, I will share my screen, sir.
So there's all sort of mess in that screen, so don't let him, sir. Okay, he left.
Oh, okay.
Wait. What? So you use VPN, not VPN.
You watch a lot of Mr. Beast videos, sir.
Say it's connected.
Sir,
to
we can
Netherlands,
see.
huh?
Sir, we
Am I
can
Yes,
see.
audible
sir,
now?
we can see.
Yes,
Yes, sir, we can
we
see your writing.
You're audible and
can
we
see
can
one.
see, sir.
See here. So example one, when a train suddenly starts moving,
Should we write
when
this?
a train suddenly starts moving,
So
The
this
passengers
example is in
tend
our
to
book,
fall
sir.
backwards.
yeah,
The foot is
Yes.
because of foot is directly or connected to the
moving forward,
Be-
the
it's
passenger
because
standing.
The foot is
shoe. Circle.
Mute
Oh.
yourself.
So you can okay.
Please you be quiet when I teach, okay? When I ask you to speak, then only you speak. Otherwise, you'll be just not able to hear what I'm saying, and then the important things will be lost in the discussion. Useless discussion. Okay?
Yes,
So
sir.
keep yourself mute and speak only when I ask.
Yes, sir.
When I say, is it okay? You just say either yes, sir, or no, sir. That's it. We'll discuss
sir.
everything at the end, whether it be the
Yes,
latest
sir.
news or be it sports, be it everything. We'll discuss everything at the end, but not during the classes, because that will hamper our studies. Okay, so see, so when a train starts moving forward, what happens? The passengers standing in the compartment tend to fall backwards. Why this happens? Why this happens? See here.
Because the lowest.
Can I answer?
No need. No,
I'll tell you. See here. What happens? So the lower part of the body, which is in contact with the train, particularly the leg. So whenever the train starts moving in the forward direction, the leg also feels the same thing at the same time, and it also starts moving in the forward direction. But the head part, okay, I'm not drawing the full diagram.
It's okay, sir. I don't want to see.
Okay, the head part, it tries to remain at the state of rest, because earlier it was as a state of rest, and like after some times when
Because
the
the
leg
mass
is
of the upper
bit
body is
here,
more.
yeah, after sometimes let us say the leg is a bit here, okay, but still the head remains wants to be the in the earlier position, okay, and then we get slant for some time, and that is the jerk that we feel at that particular time when the train gets started. Are you getting my point?
Yes, sir.
Are you getting my
sir.
point?
Yes, sir.
So
Yes,
I
sir.
want you all to write this reason behind it as homework.
Sir, can you repeat?
Okay, you'll find
Yes,
these
sir.
reasons and then you'll write it.
Sir, can you
It's
repeat
there in
again?
our book.
I wasn't able to
Yes,
hear
sir,
you.
sir,
Can you
that-
repeat
See, Tarun, see here. When the train starts moving, the lower part of the body, which is in contact with the train, also starts moving at the same time. But the upper part wants to remain at rest. After some time, the lower part moves forward, but the upper part still remains there, and that is the time we feel the jerk. Got it?
Yes. Yeah, yes, sir. Yes, sir.
So you have to write this reason. I'll explain everything, but in writing, I need it from you, and you'll show me in the next class.
Yes, sir.
Who did not do
Yes,
the,
sir.
who will not
Yes,
do
sir.
the homework will get punishment.
Okay, sir.
Sir. How
So
will
this
you
is
check,
only
sir?
this one?
When a hanging carpet
Is beat with a stick.
is bitten, with a
So I
stick.
know another
Sir,
example
and
from real
I
life.
have a
sir.
doubt, sir. I have a doubt, sir.
The dust
Sir,
particles
then
falls
why
off.
do we why do we also like have a jerk when the let's say the bus is in motion and it suddenly comes to rest? Why do we like have
See,
like a jerk even?
again
Our
the
legs
same
are
case.
going back.
Literally the same thing.
In the same
How
case,
can the legs go
when
back
we
there?
when we are in motion, when the whole body is in motion. Please let me speak, Nitish.
Yes.
When the whole body is in motion, so what happens when we are stopped suddenly? So when the bus is stopped suddenly, what happens? The lower part of the body that is in contact with the bus, it gets to stop at that same instant, but the upper parts wants to still be in the same motion. So what happens? The lower part gets stick to that position, but the upper part tries to move forward a little, and that is the upper jerk in the forward direction.
That's the inertia of motion.
Yeah, that is the inertia of motion. Earlier, this was the inertia of rest. Again, I want the same reason for this hanging carpet beating.
Inertia of rest.
How it
Yes.
happens? Now see here. Let us say this is the carpet. Okay, this is our carpet, and these are dirt particles, right? So when we
Yes,
beat
sir.
it, so what happens? The
Particles
carpet moves forward. Okay, and stops after some time. Okay, stops after some time. There's dust particles at the backside also.
Yes.
Moves forward and stops
Right.
after some time. So when it stops after some times, what happens? The particles are still in motion, so they move forward. Okay, and the particles which were at the backside, they were at the inertia of rest, so they did not move. They did not move. And at this position, what happens? They are attracted by the gravity and they fall.
Yes.
Understood? And we get a cleaner carpet.
That's also happened when we like shake a tree and then the apples and things fall down.
Yeah, same thing.
Sir.
Because
They're just
apples
telling you the
remains at
examples
its
from the book.
position and the tree moves.
I don't care.
Okay.
Yes.
Third example.
The tree and
Tree shaking one. Or we don't need that, sir. Oh wait, no, it's a striker. Oh, it's carom.
we can write it like when a smooth card,
Okay, that one.
when a smooth card placed over the mouth of a tumbler, is flicked sharply, sharply in the horizontal direction, in horizontal direction, the card flies away. The card flies away, but
So
the
they
coin,
do this in okay.
kept over kept over, the card falls into tumbler. Have you done this?
Sir, I didn't.
So they
what you have to do, you have to take a tumbler,
fancy
glass.
restaurants. Not this, like
And
they keep
then
tumblers.
over it we keep a
there.
card and then a coin. So when you will like flicker the card very fastly, okay, in a very faster manner, or you
Pull the
pull it
card.
in a very faster manner, so what will happen? The card will get away. Card will get away, and the coin will fall into the tumbler. What happened here?
So, okay.
What happened here? Nitish will explain me.
The coin is in a state of rest, and it has a tendency to stay at rest. So when they pull the card, the coin is still in rest, and the force of gravity is like made it fall
Push
down
the
into the
coin.
tumbler.
Now Taran will explain me.
So the same, sir. When you pull the card out, the coin will still be in rest. Its inertia will still be in rest, but the card will change from rest into motion, and gravity will the force of gravity will pull the coin into the tumbler.
Now tell me, what if I pull the card very slowly?
So it'll come with
Sir,
the card,
It
sir.
come.
It'll
It will
the
come
coin,
with the
sir.
coin, sir.
Sir,
Like,
then both the
why
inertia
at
of the
that
coin-
time? Why at that
Sir?
time the coin did not want it to be did not want to be at the
speed
same
is
state
a
of
parameter of inertia, sir. Speed, mass, other stuff.
No.
Okay.
That is not the answer. Kongwei, any answers?
Sir, I don't know, sir. I don't have a clear.
If we flick the card in a very slower manner and the coin goes through it, why does that
So
happen?
because speed
Mass
is the
very
deciding
less, sir.
factor of inertia.
Mass is very less, that's why, sir.
Speed is not the determining factor. And how mass got
not.
less, Nitish?
The coin, like if
If
the
the
pen
card
is
has
very,
less mass, it will be easy to pull it fast.
sir. See,
Well,
if,
the
like
coin-
No.
pen is very it has less mass. So when I pull it slowly, it doesn't move. But if I have like something like a big book or something like my math book, if I keep it on top of my thing, even if I move it slowly, it'll fall down
No.
because of mass.
This is not the
No,
answer.
okay.
This is not the
It's
answer.
very hard.
See, the answer goes like this. The answer goes like this. Exactly, if they'll ask you this question, so what you have to do, see, when we are providing enough time so that the coin also understands the motion of the card. Are you getting my point? When we are providing enough time so that the coin is also understanding the motion of the card. Okay, so now the coin will also start moving with the card. When you flicker the card in a slower manner, what will happen? The coin will understand the motion of the card, and you'll provide enough time so that the coin also starts moving with it. Are you getting my point? You don't get the
Yes.
jerk when the bus starts moving slowly, isn't it?
Yes, sir.
You get the jerk only
So
when the bus
time
starts
is
Yes, sir.
moving quickly.
So time is a deciding factor of inertia.
Yeah. What happens there,
Oh.
when the bus starts moving quickly, your upper body do not get the time to understand the motion of the lower body.
Agree.
And when it happens quickly, so your upper body, when it happens slowly, so your upper body gets the time to adjust with the motion of the lower body. That's why you don't get the jerk in the slower case. Now understood, everyone?
Yes, sir.
Yes, sir.
Yes, sir. Yes, sir.
Sir, but
Good.
I have a doubt, sir.
Yeah, go on.
Sir, can you go to a new slide?
So when you ask questions like
everyone-
that, just have to say that when the card is pulled slowly, the coin has more time to understand
Yeah.
the movement of the card to like. Oh, okay, that's it. Okay, Sankalp can ask the question, sir.
Sir, let's say that sir, like, can you keep drawing while I'm telling, sir?
Go on, you go on.
Sir, let's say I am in a train and I have a coin in my hand. And let's say I flip that coin is in the air and the train is moving 100 kilometers per hour. So how does the coin, when it is floating in the air, still know the motion of the train, sir?
When you flicked it, you were in
And
motion.
come back
No.
to your hand. And it come back to your hand.
Sir, but like the train is in 100 meters per hour, right, sir? So like, sorry, 100 kilometers per
100
hour, right,
meters per
sir?
hour.
And
100
100
meters per hour.
kilometers per hour, right, sir? So when you flick it, the coin is in midair. How does that coin know that this
That where you are.
train that it is in, where you are, is going 100 kilometers per hour?
This is a question which I had when I was a child.
See,
The
this
question
is something. See, this is something related with the motion chapter of class 11.
Broda.
Okay. Okay. This is
It's
not
like you
related with
throw a
forces.
ball. It's like you throw
Still,
a
I'll
ball
try
in
to
air and
explain.
then you go to where it goes and you catch.
I'll try to explain you. See what happens.
But then
But
when he flicks the coin, and when he flicks the coin, if the
Here.
car is at rest, it won't come back to us.
please let
when
me
the
understand.
car is
No. No. See here. If you throw a ball upwards and or any coin upwards, and then you will be understanding that after some time you have moved forward with the train, but still when you ball you threw upwards, it came back to your hand only.
Yes,
Are
sir,
you getting my
that's
point?
question. Yes, sir, that was my question.
What happens
But-
there? See, there are two velocities. One velocity, what you threw it upwards. Another velocity it acquired with the train, because the train was attached to you. You were attached to the ball. So the train's velocity got transferred to the ball. Now the velocity is something like this, and this is what happens.
So I
with
think
You won't
he
understand
asked.
this.
So I think he asked if we flip a coin when the train is at rest, and suddenly it goes.
That's what
100
I'm asking.
kilometers per hour.
That's
I
what
don't
I'm.
know
That's
what
what I'm telling. That the velocity of the
So,
coin did not
my
get
doubt was
velocity of the
what
train
was-
did not get transferred to the velocity of the coin while being in midair. It got transferred to the coin through your contact.
Yes, sir.
But we were at rest when we threw the ball, sir.
You are at rest with respect to the train, nah. But if somebody will be seeing you from outside, he'll be telling you that you are with the
So
same speed
entire
as
train is
that
at
of the
stop,
train.
sir. The entire train is at stop when I throw the ball, then train starts to move.
That's
sir.
not
That
his
time
doubt.
the ball. I am asking that.
Okay.
That's
Sir,
not-
I have a doubt. Sir, just
Then like the ball will be at the same
the
place the train will.
train is going at 100 kilometers per hour.
It'll go like
You
that.
throw the
back.
ball, and just imagine that it suddenly stops. Like it doesn't stop slowly. It suddenly stops there. Then what will
Yeah.
happen? Will the ball still come to you, or it will go far?
No.
When you
The
throw
ball,
it, it will
then the ball. That's a good question. That's a good question.
It will fall in
When you
front of.
throw the ball, while being with the speed of the train, so you provided the velocity of the train to the ball. Now the ball is in midair. It has no transfer of velocity, that it cannot understand the train has stopped. So it will travel that oblique path only. And you are at the same position, the ball will fall after you. Understood?
Yes, sir.
Okay. Now let us
Like,
stick to
why
our
does
syllabus.
this
Ball
not
100
work?
kilometer per
Why does
hour.
this not
No-
work when
no
I am
further
in
question.
the train?
No further questions. Sankar asked questions.
These
now,
questions
never
are like apart from your syllabus. That's why I'm not entertaining these things. Try to stick to your syllabus. You don't ask questions from your syllabus. These things I need to explain you many things. I'll have to explain you projectile. I'll have to explain you relative motion. I have to explain you projections. So unless and until you will not understand these things. Okay, I just gave you an idea that this happens. Okay, I cannot explain you the whole concept. Now see here, inertia of motion. Earlier we dealt with inertia of rest. Give you the topic. The previous slide, the examples that we did, right here, inertia of rest. At the top, you write there. Now we'll be discussing inertia of motion.
of motion.
Okay, a cyclist riding along a level road does not come to stop immediately after he stops cycling. Okay, why? Because once he was in motion, he will try to be in the same motion unless and until an
Yeah.
external force is provided. But he will stop after some time. But the cyclist will stop after some time. Why?
Because the
Because there
slope
is
is
no
ended and it's a
force that
flat
is being-
platform.
I just want
Because
one
of-
word. One word.
Friction.
That's good.
No, law
That is
of
the
inertia.
reason. Friction will make the body stop. Friction will provide an opposing force of the towards the body, and then the body will stop. Okay, that's why.
Sir, no external
If friction
force.
was- yeah, if the friction was not there, the body will keep
Reverse.
on moving. Okay, and we
Go
have
like forever.
when
That's 3 words.
a passenger jumps out of the moving train,
My God.
jumps out of moving train,
People do that. Because they will fall down
Moving
like
train.
when they land on their foot, like the
Hmm.
foot will alone go back, and then the foot
They
will
will-
be at rest with the ground, and but our upper body will be is still in the train's motion, so we will fall like
Yes, sir.
right like
Yeah,
wherever,
exactly.
whichever direction the train.
See,
I saw
I'll
a
explain
video
here.
about that.
Yeah, that's correct. See here.
Comedy.
So if the train is moving with some velocity v, you are also moving with the same velocity, and when you jump out of the window, out of the door, so what happens? Your lower body will try to follow the same velocity v, but your upper body will be at rest. Oh, I'm sorry. See, your upper body, now upper
I was
body will
confused,
follow
sir.
the same velocity.
I was confused.
Upper body will try to follow the same velocity, but your lower body will suddenly come to at rest because the ground is v is equals to 0. Okay,
Yes, sir.
so one more question comes: you'll fall forward or you'll fall backward?
Fall
Sir,
forward.
backward, sir. You'll fall backward.
Forward.
Forward.
If the train
No,
is moving
forward.
forward, it will jump. The velocity will be in the train's direction.
So we will
No,
fall
you'll fall forward. You'll fall forward. See what happens. Let us say that you were in motion. Okay, you were in motion. Okay, you were
Sir,
in motion like this.
Sir, it depends on what angle you see. I saw it from the back angle. So he's falling towards the left side.
No
If you see it from the
way.
front
See,
angle, he'll
it
be
all
falling.
depends on the moving direction. I'm telling you. See here. If you're moving in this direction and you just jump out of the train, and then what happens? The lower part of the body was at rest, and the upper part will still be moving. So you'll fall forward like this. Okay.
Yes.
So that's why it is told, if you're jumping out of a moving vehicle, what happens? You just have to run for some distance with the same speed and then slowly decrease your speed. You must have seen people jumping out of a bus and then running for 2-3 steps and then stopping out.
Yes,
Isn't
sir.
it?
Sir.
Yes, sir.
Because I
I
studied
think
That is the
physics
reason.
proper.
stupid more than enough to understand that. Sir.
If they understand physics, even if they have not studied.
Yes, sir.
Okay.
So it's pointless studying
I
physics.
think it's common knowledge. Like, they don't know what.
Then we have that example: a ball thrown upwards. I want all these explanations that are written here. Ball thrown vertically upwards. Vertically upwards by a person. By a person.
Sure, there you go. Okay, nothing. So this is what I mean. This is what Tarun asked.
Yeah. In a moving
So this is the
train.
So this is not what. This is
Comes
what I
back
asked.
to his
Not
hand.
Tarun asked different.
No, this is not what you asked. You asked for inertia of motion. I mean, not this one. Like,
Little bit the same thing.
oh yeah, this is what Sankalp asked.
You
Okay,
understood?
not Tarun.
Everyone understood this example? Everyone understood this example?
Yes, sir.
Yes, sir.
So write these 2 pages
So,
quickly.
wait,
Written
can you
this
show the
one?
previous song? So one
Yes,
second,
I
one
wrote.
second.
I wrote.
Wait.
I wrote this.
Sir,
Can you
I
go to the
finished
next
this
one?
page.
Okay, take your time, write it down quickly.
Sir,
So I
finish, sir,
finished this,
finish.
so you can go to the next page.
Tarun, done? You are mute, Tarun.
Muted.
You
Yeah,
just have to
muted.
write the
Sorry.
reason, right, sir?
Sir, I finished this. Can you go to the slide which that
Okay.
guy jumps?
Now write this one.
Yeah.
Yes, sir.
Sir, you have to do this as a homework.
To explain these were the statements. You have to explain these. Okay, all detailed explanation I want.
Yes,
Right.
sir.
Yes, sir. Done, sir.
Sir, I finished, sir.
One written.
Yes.
So 1 second, sir. 1 second. Don't teach anything. 1 second.
Done, sir.
This was the question which Sankar passed,
Yes.
right?
Nitish left.
Sir, I am back, sir.
Yeah.
I am back. Okay, now you can teach, sir.
Respawn.
Right.
Shall we continue? Everyone written?
Sir.
Yes, sir.
Now we'll be studying the Newton's second law of motion. Topic says
P is equal to mv.
linear
F is
momentum.
equal to ma.
No, it's written different in the textbook. I
You
don't
can
know.
use it as. It's most commonly referred to as F is equal to ma.
Second law of
No.
motion. So first thing that we need to define here is momentum. That is denoted with the sign P. It is the product of, as I said earlier, it is the product of,
Mass and velocity.
very good, mass and velocity. Everybody understand this? Why this was introduced? I told you that the mass is only not required to calculate the force. Somewhat the velocity is also relatable. And then the scientists found out the relation between mass and velocity, that is called the momentum. And then they related this to force. I explained all these things in the previous class, right?
Yes, sir.
Yes, sir.
A second law of motion says that statement. First, let me write the statement. Second law of motion. Statement of the second law of motion. According to Newton's second law of motion,
What?
the rate
Yes,
change of
sir.
momentum. The rate change of momentum. Rate change of momentum of a body is directly proportional to the force applied on it, and change in momentum takes place, and change in momentum takes place in the direction in which force is applied. You first write this, then I'll explain you.
Yes, sir.
Write this, everyone.
I'm writing.
Done, sir.
Done, sir.
Done, everyone?
Yes, sir. Everyone is done, sir.
Okay. So what happens here?
Sir, done.
As the statement says that the force is what is rate change? Tell me.
Rate
Tell
of
me
change,
somebody rate
like
change.
Sir, rate of
is,
change is the rate at which something changes. Okay, yes, sir.
I told you, in motion in one dimension,
Sir,
I explained you. Rate change means
sir, how
change of
fast?
anything with respect to time. The change
Yes,
of
how
anything with
fast
respect to time. Yeah,
something
it can be
changes.
said like that. Rate change means change of anything with respect to time. For example, if I say that the rate change of distance is what? So change of distance with respect to time is speed, right?
oh, in our speed. Okay.
Sir, what
Okay,
is
and
the
then
first word in statement?
According
to which, according ACC, according.
Okay.
Okay, so rate
What
change
did you
means
say?
what?
What was
Change of
rate
anything.
change?
according.
Pardon?
Nothing, sir.
Listen here, rate change of anything means change of anything with respect to time. So what he said that force is directly proportional to change of momentum with respect to time. That means let us say the final momentum is P final and initial momentum is P initial with respect to time. This is what they're talking about. That is force.
Yes,
sir.
sir.
Okay. Okay. Now what is P final? If a body is there, it has mass m and it is moving with velocity v. Now you apply some external force on it. You apply some external
sir.
force on it. So it's not, let us apply horizontally only. You apply some external force on it, okay? And what will happen? The mass will remain same and the speed will increase. Let us say vi was initial speed and v final is final speed. The speed will increase in t time.
Sir.
Yes, sir.
This will happen if you apply force. Like if ball is there and you hit it with a bat, same thing will happen. Mass will remain same and the speed will increase, right?
Yes,
Sir,
sir.
velocity will increase.
Sorry, velocity will increase. So can I
Yes,
write
sir.
the initial momentum? This is P initial. Initial momentum as m into vi, and can I write the final momentum as m into vf, because m will not change during the force applied, isn't it?
Yes, sir.
Yes, sir.
Because the body will remain same. So can I write the same thing as mv final minus mv initial upon time? Can I write this?
Divided by time is equal to force. Yes, sir.
Yes,
So the rate
yes,
of
sir.
Now-
change of velocity is equal to acceleration.
Now see here. Can I take
What's
mass
that?
as
What's
constant
that?
outside
That's good.
and then I write it like this? Mass constant outside and then write it like this?
Yes, yes, sir.
Yes, sir.
Now can I write it like this? V final minus
So it's
V initial upon
Mass into acceleration. Mass into acceleration.
exactly. So V final
Yes,
minus V
sir.
initial by T is what? Acceleration. So force is mass times
Acceleration.
acceleration. And this was derived from the Newton's second law of motion. Now did you understand, everyone?
F equals ma. Yes, sir.
Have you written
This was derived from
V1
here.
and V2?
Nitish.
Sir, have you written V1 and V2?
V final
Sir,
and
one
V
second, sir.
initial.
Let me write it down. Let me write it down.
VF and VI, da.
P,
VF and
final
P
VI.
and V.
is the rate of change of momentum, sir.
Basically,
Now
V
first
and
tell
U.
me, everyone, did you get it?
Sir, but P is the rate of change of momentum, right?
No, P is momentum only. And it was said that the
Oh,
rate
yeah.
of change
Oh,
of
okay.
momentum is force.
Oh,
Everyone understood it or not?
yes, sir.
Yes.
Got it, everyone?
Yes, sir.
Yes, sir.
They'll ask you
One
this
second.
in
Oh,
exam.
1 second. I'm writing.
They'll ask you this in
Don't
exam.
change it, sir. Give me.
Sir, P is for what?
Don't change it.
V is velocity of the body. V final is final velocity of the
P,
body.
sir.
V is initial velocity of the
Just in
body.
P.
No, sir. The P.
P is momentum. P is momentum. You see that momentum definition I've written P. P is a denotion of momentum. Like we write V for velocity, we write P for
Yes, sir.
momentum.
Yes, sir.
1 second. I'm still doing it.
Done, sir.
Second,
No, sir.
sir.
Wait.
1 second.
Okay, sir. Done, sir. Done, sir.
Sir, 1 second, sir.
Okay, take your time. I'm waiting.
Sir, but how can it be acceleration if it's divided by the whole time, sir? Then mass should also divided by time, right, sir?
It is.
How foolish thing you're talking about. If you're doing something 2 into 3 by 4, is it like 2 by 4 into 3 by 4, or we just have to divide one time by 4?
Okay, sir.
Understood?
Yes, sir.
Yes,
This
sir.
is wrong.
You're coming
It's
right
just one
after
time.
math
So
class and
either I
speaking like
divide it,
this.
either
Very
I write
disappointing.
it 2 by 4 into 3, or I write it 2 into 3 by 4.
2 by
Or
5.
you write
Oh,
it 2 into 2, and then you put bracket, and then you do 3 by 4.
But 2 by 4 into 3 by 4 is also equal.
No,
It's not.
when you're
Oh, so,
talking-
sorry.
It's 6 by 16. You can
And
only
the
do like that
last
for addition.
yes, sir. I finished, sir.
1 second, I'm in last line.
Sir,
Did
proving
long
some
back.
feeling. 1 second, sir. I'll respond again, sir.
It's sir left.
Oh, proving
It
someone.
says the host is
proving-
facing a technical issue and is expected to rejoin soon.
No, not 20 minutes.
Otherwise,
19 minutes. Oh no, I have a class at 7 o'clock now. When will this class end, bro?
7 o'clock.
Yeah.
What class do you have?
piano.
Keyboard. Piano. I don't play piano. I
Piano.
play keyboard.
Cardboard.
It's a big difference, Dad.
Hey,
No,
piano
I
is
was
like
still
not
writing.
electric- Hey, shut up. Piano is not like
Hey, P
electrical.
for
right?
piano, K for
Natural
keyboard.
sound, bro. No, da. Keyboard is an electrical instrument, right? Like it's not like it doesn't make natural sounds.
Do you see
Whenever
the
it's
notes
like
written, everyone?
yes, sir.
Yes, sir.
Yes,
We're all
sir.
done.
Okay. So now just one more thing I wanted to tell you. See here.
Yes, sir.
If they'll be asking you the graph between
So you're not screen sharing.
It's okay.
Please not be shared. Is it visible now?
Sir.
Yes, sir.
Yes, sir.
Sir, can you show the previous slide for a second?
Yeah.
Didn't write the formula.
Written.
No, sir. Yes, sir. Yes, sir.
Now see here. Now, as I told you that force is equals to mass times acceleration, right?
Yes, sir.
Yes, sir.
If I want to draw the graph between force and acceleration, will I say it is directly proportional? That means if you increase the acceleration, the force will also be getting increased.
Yes, sir. Yes,
Yes.
Yes, sir.
In case of mass also, if the mass is increasing, the force will also be getting increased.
Sir.
Yes,
Yes,
Yes, sir.
Got it?
Yes,
Yes,
sir.
sir.
Yes, sir.
And if you want to draw the graph between acceleration and mass, so can I write acceleration is equals to force upon mass?
Yes, sir.
Yes, sir.
If I put force constant, is acceleration decreasing with increase in mass?
Yes,
Yes,
What?
sir.
What?
Yes.
If I put
Because
force as
I-
constant, and this force is not changing. So if you increase the mass, the
Okay.
acceleration will decrease now.
Yes, sir.
Yes, sir.
Because in
Yes,
the
sir.
second graph, we see that.
Oh, yes. If
Understood,
F
everyone?
is not a constant, it won't be like this, right?
Yes, sir.
Yeah, it
Ah.
can be anything.
If is not
Maybe
constant, we
amoeba.
cannot predict. So write these three graphs, draw these three graphs, and then we'll be ending here today, and we'll be solving some questions in the next class probably.
Yes, sir.
Okay, sir.
Everyone understood? Any doubt anywhere?
No, sir.
Sir.
No, sir.
We're clear.
So what if M
Got
is constant and F is like F and A are like directly proportional, sir.
We do the same thing here. If you are drawing graph between f and a, we have to consider m is constant. The third parameter is if we are considering f and m, we are
Yeah.
considering a as
M
constant.
will always be constant.
No, it won't be.
Okay, what
If you
about
change the
the
mass, then
acceleration,
What can you say?
So, but in all the examples we saw, M was always a constant.
now we consider it. We consider it
What
to be
if,
constant.
like,
It's a
I'm
constant
pushing
if
a
they give the
water?
value, da.
What if I'm pushing a
They can
tumbler and
change the
constantly
value.
pouring water into it?
Okay, done everyone.
Change.
Yes, sir. I'm
Yes,
done.
sir,
One
done,
second.
sir.
Yes, I'm done.
Tarun done.
I have a plan.
No, sir, 1 6.
Yes, sir.
I have a plan.
Thank you, sir. Bye, sir.
Sir, I don't know if this is true or not, but Nitish said today morning that scientists have discovered flying spiders. Sir.
Actually, check on
Flying
Google.
spiders. I don't know.
Actually,
Flying
sir,
spiders,
they
sir.
discovered it somewhere.
Hey, they probably just took a
Actually,
bird and
I-
named
they-
it spider.
No,
They are
it's
not
like
like that.
real
I
news,
guess,
sir.
I
It's a
guess, I
fake
guess,
news,
I
sir.
guess Nitish
Check
is
Google,
finding
check
that spider
Google.
so that he get bitten with it and then he becomes Spider-Man.
He'll become Flider Man.
Spider man.
Sir, they
New
don't
idea for
actually
Marvel.
have wings, sir. Like it's a different. It has the ability to glide.
It's probably
like,
flightless. It'll have wings, but it's probably flightless.
I hope
It's
you're
like
not
the
trying to
penguin.
find it to get bitten by it.
Sir, not here, sir. I don't like spiders generally, sir.
That's why I'm not Spider Man
Okay.
yet.
I like that character. I just don't want
Done
to.
everyone?
Yes, sir.
Yes, sir.
Yes, sir,
Done.
done, sir.
Thank you, sir.
Sankar written?
Sankar, you go check the now. Check
Yes,
sir.
sir.
Tarun written?
Sir,
Sir,
Sir, I finished, sir. Thank you, sir. Bye, sir. I have to.
so when is the
thank you,
next
sir. Bye,
class?
sir.
When is the next
Bye,
class?
sir. Sankar, you check now.
Next class, I guess next Monday.
Yes, stay there.
No, I have class.
Yes, sir, thank you, sir.
Yes, sir. Thank you, sir.
Okay, then
sir.
bye.
Sir.
Yeah.
Vedant. Sir, do you have any chance of correcting my, the previous test paper which I did? Motion and
I
one
cannot
direction.
do that, Tarun. I cannot do that, Tarun. Please try to contact
Sir,
administrators for it. I don't have any such authority to check your paper personally because I cannot check anyone's paper. I have not seen anyone's paper. So try to contact them and ask them that where
Yeah,
is
they
the
can-
paper gone.
Yes, sir. Thanks.
Sir,
Okay.
so Nitish was right, and spiders do glide, sir.
There may be some species of it. Okay, then bye.